Hey guys, this is the lecture on carbon timescales. So before we get into the timescales though, we're going to go over a couple of units and how we actually discuss carbon with the units. So most of the time you'll hear parts per million, which is actually the number of molecules of carbon dioxide over the number of molecules of air. So if you have one molecule of CO2 for 100 million 1 million molecules of air, then that's this number, which ends up being 1 part per million. I don't know why there's a decimal there. It wasn't supposed to be. Sorry, guys. But more realistically, where we are right now is closer to 400 molecules of CO2 over 1 million molecules of air, which is going to be 400 parts per million, which we just hit 415 last year. So we just keep getting more, because I have some lecture slides from when I taught global climate change a couple of years ago, and I think that it says like 350 in them. So we're definitely increasing that number faster than we would like to. But that's like if we're talking about the amount of them in the air. If we're talking about the mass, then we're going to use more of a petagram. So 1 petagram is this number grams, or 10 to the 15 grams of carbon. So you might hear them one way or the other depending on, I don't know what you're reading. Sometimes you'll also hear the term gigaton, which is going to actually be the mass of all land animals, not humans though, on Earth. So that is what 1 gigaton is. It's all the animals, land animals, minus us. Or if you want to look at just humans, then you can say 2 times the mass of all humans on Earth is actually what a gigaton is. Okay, so on the timescales, we're going to start at these larger timescales, and we're going to kind of go down into, smaller timescales. So the first one is going to be timescales of hundreds of millions of years. So this is going to be, a graph where we have the CO2 in parts per million here on the y-axis, and on the x-axis, we're going to have millions of years ago. And you can plainly see there's something that happens, here right at, I don't know, what is this, like 300 and maybe 320 million years ago, and something that happens here, another time period further, and then there's something that happens right here as well. These are the types of things we're going to be looking at, is what caused these differences in, carbon, or I'm sorry, CO2 in the last, in these millions of years ago, decade or time periods. When you're thinking about this, think about in this time scale, think about things like, when was the first landmass formed? When would that be in this graph? Also, when were the formation of plants, the first plants on the planet? Also, the first dinosaurs. Because, plants are going to be going through photosynthesis, are going to be taking in carbon dioxide, and also the dinosaurs will be breathing out the carbon dioxide and adding to the CO2. So, think about those types of things when you're looking at hundreds of millions of years ago. Now, if we're looking at something like 100,000 years ago, you can see that that goes in a cycle here. Right? What would be causing that? What other mechanism operates on a time scale of 100,000 years? You might already actually know that one. Okay, and this one is going to be hundreds of years. This should be familiar to you guys. This is the hockey stick graph right here. We all know right here, Industrial Revolution, right? That's pretty much what caused this spike right here. Again, we're looking at parts per million. In volume, actually, but this is like what we're actually, this is hundreds of years. So this is kind of cool. All right, and then we can go down to decades. This is the famous Keeling curve. This should also be familiar to you. This is available since 1960, and what's super cool about the Keeling curve is the resolution. We have pretty high resolution of available, parts per million of CO2. Now, you guys know at Mauna Loa Observatory in Hawaii. Let's see. Oh, also this data is available on NOAA's website. So if you guys ever want to get a hold of CO2, throughout these years, it's on the website. It's archived. So you guys can just look that up. Let's look also at timescales in 1 year. This also has like a cycle to it. Seasonal cycles. That makes a little sense, right? Because in the higher latitudes, we have plants that are dying, contributing to the carbon in the soil, but no longer taking carbon dioxide out of the atmosphere. So we're going to see, a cycling actually through the seasons with respect to carbon dioxide as well. But let's look at one day. We're seeing a little bit of cycling right here too in one day. Well, this has to do with light, the diurnal variation of light. Okay, plants are using that for photosynthesis. So the plant activity are going to change. Respiration is going to change throughout the day. Also, you can see a difference during the day in anthropogenic, because of anthropogenic sources, but that is very dependent upon where you live. So I don't think about that one as much. So these are the types of things that when we're talking about timescales, when we start going into the actual carbon cycle, which scale are we thinking about? How fast is that carbon going to move through that reservoir? Okay, we'll see you in the next video.